Alright guys, welcome to today's class. Today we'll be discussing product rule. And please, if you haven't subscribed to our channel, kindly do well to subscribe so you get notifications when I upload new videos. Now for product rule, if you have y equal to u times v, if y is equal to two functions multiplying u and v where they are functions of x. If two functions are multiplying this way, we apply the product rule. And what is the product rule? That dy dx is equal to, you keep your u, differentiate your v with respect to x, dv dx, plus then keep your v, differentiate your u with respect to x, du with respect to x. This is our product rule. uv, keep your u first, differentiate v with respect to x, plus we need to make sure it's a plus in between, and then keep your v, differentiate your u with respect to x. That is our product rule. So what you simply need to do, if you have two functions multiplying, identify one to be your u, identify the next one to be your v, and differentiate, apply your product rule. Now let's look at some practical examples that will best explain this product rule. Okay, let's look at these practical examples. Differentiate the following. 1. Y equal to sine x cos x. 2. Y equal to exponential x sine x. And 3. Y equal to x squared plus 3x plus 1 into x squared plus 4. Let's look at solutions to these questions. And if you look at this question, you see that these functions are multiplied. Sine x cos x, two functions multiplying. Exponential x sine x, two functions multiplying. Then this is an algebraic function, another algebraic function multiplying. So we are going to see it as product rule. Right, so let's write the rule here. For product rule, dy dx is equal to u dv dx plus v du dx. This is our rule. Now please note that this rule, we can start with v du dx first before our u dv dx. So either you keep this term first or you keep this term first, but always maintain your plus in between, maintain your plus. U dv dx, keep your u, differentiate your v with respect to x, plus keep your v, differentiate your u with respect to x, and that's your product rule. Now let's look at the solutions to this example. For the number 1, we have y equal to sine x cos x. Now, we need to identify the type of rule that should be applied here. We have sine x, a trig function, cos x, another trig function. They are multiplied together. Product rule. So we'll call the first one u, call the second one v. So our u is sine x. This u, and then our v is cos x. So we now have uv. Now the next thing is to differentiate u and also differentiate v. I will differentiate u with respect to x. When I differentiate sine x, I have cos x. And when I differentiate v with respect to x, it means I will differentiate cos x. If I differentiate cos x, I have negative sine x. Remember, the derivative or the differential of sine x is cos x, but the differential of cos x is a negative sine x. I differentiated u and v. Now I can now apply the rule. What is dy dx now? Dy dx. Apply my product rule. I will start from u. I will write my u. My u is sine x. And then I will write my dv dx. dv dx is minus sine x. So it's a minus sine x. And then there is a plus. I'm following this rule accordingly. There is a plus. I'll write a plus. And then the next part is your v. For my v, I have cos x. And then du dx. du dx is also cos x. Okay, so I have u dv dx plus v, look at my v, then du dx cos x. Now I can just open up this expression. This will give me sine x times negative sine x is a negative sine squared x plus cos x times cos x is a cos squared x. I can write this as, let me bring the positive value first, cos squared x minus sine squared x. At this point, I've already gotten my derivative, my dy dx, but I'm just trying to simplify further. If you have a trig function, from basic trig knowledge, it is possible to transform these trig values to a singular name, to one name. Alright, so if I have cos squared x minus sine squared x, I can keep my answer like this. That's very fine. But I still know another trig value that has this value, cos squared x minus sine squared x, and that is cos 2x. In simplification of trig function, it is better to keep it to this general name. After doing your derivative, when you are simplifying, reduce it. If it's possible to reduce to one singular name, you keep it in this singular form. But if I keep it here, it's still okay. If I keep it here, it's still okay. Right, and that is the solution to this problem. Okay, let's look at the next question. Y equal to exponential x sine x. Y equal to exponential x sine x. Now, if you look at this function, we'll see product of two functions, the exponential function and the trig function. Alright? Now, we just need to identify our u and v. We identify u and v, then differentiate them, then apply our product rule. So, our u is the first one, exponential x. And our v is the second function, sine x. The next step is to simply differentiate u with respect to x. Differentiate u with respect to x. And if I differentiate exponential function, exponential x, if I differentiate exponential x, it is still exponential x. So I have exponential x. And then if I differentiate v with respect to x, if I differentiate sine x, it is cos x. I've gotten my du dx, dv dx. The next thing is to now put in my product rule. Put everything in the product rule. It means that my dy dx, I would now follow strictly my product rule. U dv dx. Keep the first term, differentiate the second term. If I keep the first term u, I will have exponential x. And then the derivative of this second term, dv dx, it is cos x. Alright, then there is a plus. Then v here, v is sine x. And then du dx. Du dx is exponential x. So here, this is my dy dx. But I can still factor out common term. I can simply say this is, let me factor what is common, exponential x. Then this is cos x plus sine x. This is my dy dx. If I keep it here, I'm still correct. If I simplify to this form, I'm still correct. Now let's look at the third example. Y equal to x squared plus 3x plus 1 into x squared plus 4. Okay, for this example, we need to identify our u and our v. This first part, we'll call it our u, and this second part, we'll call it our v. Two algebraic functions multiplying together. So let's say this is our u, x squared plus 3x plus 1, and this part, let's call it our v. V equal to x squared plus 4. We've known our u, we've known our v. The next thing is to know our du dx and also find our dv dx. Our du dx will be equal to, if we differentiate x squared, we will have 2x. If we differentiate 3x, we have 3. And then we also need to find dv dx. dv dx. If we differentiate x squared, we have 2x. If we differentiate 4, differential of constant is 0, so that's off. Okay, so we've gotten du dx and dv dx. The next thing is to put in everything into this formula. It means our dy dx. Now, dy dx is u dv dx. We keep our u first. We are going to follow this formula strictly. Keep our u, hold our u, x squared plus 3x plus 1. Then multiply it with dv dx. Our dv dx is 2x. The next part is plus. We are following strictly. V is x squared plus 4. And then our du dx. du dx is 2x plus 3. This is our dy dx. The next thing we can just do is to simplify. Open up the bracket. From here, we have x squared times 2x. We have 2x cubed. Plus 3x times 2x. We have 6x squared. Plus 1 times 2x. We have 2x. Now we also have on this part, we need to open up this bracket too. We'll distribute this into this second bracket. X squared times 2x. We have 2x cubed. X squared times 3, we have 3x squared. 4 times 2x, we have 8x. Then 4 times 3, we have 12. And this we can now collect like terms, add up like terms. And we will want to collect like terms here, we'll collect them according to their powers. So power 3, we add up power 3. Power 2, we add up power 2. Power 1, then constant value will remain. So we have 2x raised to the power 3 plus 2x raised to the power 3. That will give us 4x raised to the power 3. Plus, then power 2, 6x raised to the power 2, 3x raised to the power 2. That will give us 9x raised to the power 2. We are done with power 2, power 1, 2x plus 8x, we have 10x. Then the constant term, 12. This is our dy dx. Now let's look at more examples on product rule. If you have a function y equal to x squared exponential x sine x. Now let's look at how we can differentiate this function. If you look at this function, we have algebraic function multiplying exponential function multiplying trigonometric function, right? So it's not just two functions. We have up to 3 functions multiplying together. We can still apply product rule here. What we simply need to do is to split these 3 functions into 2. Combine them in 2. Call one side u and call the other side v. Alright? I can combine this as my u and then this one as my v. Or I can take these first 2 as my u and the last one as v. Anyhow I want to combine them, it will give me the same result. Now, I would like to take this one as my u and then combine this as my v. If you want, you can also combine this one as your u and this as your v. The same result at the end of the day. So, for product rule, we need to find our u. Let me call this one u, x squared. And we also need to get our v. Let me call this one v. So I combine these two as v and then this one as u. Alright, that's the first step of product rule. The next thing is to find our du dx, which is when you differentiate x squared, you have 2x. Alright, the next thing is to find our dv dx. dv dx. Now, if you look at this, our function v, we'll see 2 functions multiplying, exponential x and sine x. And we know we need to apply product rule because whenever you see 2 functions multiplying, you must apply product rule to differentiate them. Okay. Now, directly, we will apply a product rule directly here. We'll apply a product rule directly here. And product rule says, hold your first term, then differentiate your second term. I hold this, differentiate sine x, I will have cos x. Then plus, hold your second term, differentiate the first term. Hold my second term, differentiate the first term. If I differentiate exponential x, it's still exponential x. Okay, and this is my dv dx. I can rewrite this. I prefer writing my exponential function before my trig function. It is still the same thing anyway. It is still the same thing, but I enjoy writing my exponential before the trig. Exponential before the trig. So this is my dv dx. Now I've gotten my u, gotten my v, gotten my du dx, dv dx. The next thing is just to apply my dy dx, the product rule. And by product rule, dy dx will be u dv dx. U is x squared. Then dv dx is exponential x cos x plus exponential x sine x. That is my dv dx. Then a plus, then v here, and following this formula directly, this rule accordingly, v here, v is exponential x sine x. Then my du dx is 2x. This is my dy dx. The next thing I could just do is to simplify. If I simplify, if I open up this bracket, I will have x into this is x squared exponential x cos x plus this into this x squared exponential x sine x. I've opened up this. If I open up this, I'll prefer to bring out my algebraic function before every other function. This is 2x exponential x sine x. And this is my dy dx. I can further go on to factor out common terms, but this is my dy dx.